Why does EBRO present a new product for end position monitoring? To answer this question, we look at the world above the valves and even above the actuators. End position monitoring of valve is required wherever information about the valve is needed in control and instrumentation systems. This means that if it's an open or closed, this signal is generated at the valve, transmitted electrically, and then processed further. To differentiate, in the field of end position monitoring, we're talking about pneumatic actuator technology products, gearboxes and hand levers. The technology behind end position monitoring can be roughly summarized in two groups. These are, on the one hand, the basic version with mechanical switches and, on the other hand, electronic switches, in the technical language, inductive proximity switches. We look at the first group of mechanical switches. An actuator activates a changeover contact that switches the signal. This type of switch is very inexpensive and simple, but has decisive disadvantages. For example, they're subject to wear. This is where electronic switches come in. In the end, they do the same, but function contactlessly and transmit the signal electronically without proper switching contact. A nice, clean solution. And now you can probably ask yourself, what more do I want? This is only a small selection of sensors that we use for end position monitoring. I have recounted. EBRO offers 431 different sensors in 23 styles from 20 manufacturers. In addition, there are 91 different mechanical switches, and really all do the same, open up to open up. Not only do we use many different types, they're also really expensive. And this is it? Open, close, and open, close? We have too much variety, too expensive sensors, and we have a lot of potential. And this is exactly why the third item here is SBU Advanced. In addition to the SBU Basic and the conventional sensors, we have here a real alternative to all inductive proximity switches. The solution was created in form of a circuit board that is one-to-one compatible with the other two versions. The differences start with the fact that you won't find a conventional switch on the board. Here sits a so-called Hall effect sensor. This sensor reacts to a magnetic field strength, in other words, to the strength and direction of a magnet. Such magnets are located in the actuators and, moreover, the sensor, which continuously measures the value. Like conventional sensors, the circuit board then signals the end positions of the valve, open or closed. If you look at the box right now, you might ask yourself, why is there still so much electronics on the circuit board? This has the background that you first have to evaluate the signal of the Hall sensor and generate the message to the outside. This happens in a microcontroller that can be imagined as a mini computer that can record, process, and output many signals. These functions are freely programmable in the form of software running on the microcontroller. Fact is that the end position monitoring is not a big problem for a microcontroller. And precisely because we have integrated such a device, we do a few more really exciting things in the background. There is an additional signal with an error message. The box receives the control signal of the MV and also notices when the actuator starts. And if something is wrong during operation, problems with the valve, actuator, MV or the air supply, an error message is output. The switching cycles are counted. Quite simple and so meaningful about what the valve has already achieved. Actuating time. Problems, as described above, are not only reported, but are measured continuously, averaging again and again, to see how the operation changes over time. The temperature is measured and recorded in a history. This is the functional scope of the pure SBU, and it would also be quite interesting to read and view the data in the field during operation. This is exactly what the blue module in the lower area is responsible for.
Und genau dafür ist das blaue Modul zuständig.
At the beginning, I asked why EBRO introduced a new limit switch box. The answer is quite simple. Because we now have a solution that is higher quality than a mechanical contact, at the same time significantly cheaper than all inductive proximity switch solutions, and technologically raises the whole issue of end position monitoring of valves to a new level, provides data, and thus makes the entire unit truly transparent. That's why we call this entire package Smart Valve Monitoring.